Perfect. Welcome back to the new lecture session on waves. The outline of the lecture, waves, are given here. A prelude of the physical wave will be given here in this discussion section. The classifications of the mechanical wave will be discussed here, and some of the terminologies used in the previous oscillation section will also be used here. What will happen when two or more wave trains are moving in the same direction? That will lead to the superposition of waves. That will be discussed here. We will derive some expression for the speed of the wave, and wave equations for both the transverse and longitudinal waves will be derived. Finally, we will solve some problems like that we did in the previous classes. We will discuss what is a wave. This term will be explained using a kind of tool like the still pond water. Now look at these two videos. Concentric circles are formed. The motion of the water elements on the surface of deep water propagates a wave in which a combination of both transverse and longitudinal displacements are produced. Look at the ray diagram that when you put a stone on the water, immediately wave fronts are formed and they are moving from left to right. A wave is a physical phenomenon characterized by its frequency, amplitude, and wavelength. Okay, perfect. The whole world is filled with filled with or covered by just two types of waves or two types of entities. They are one, the mechanical wave, and the other, the second one is the electromagnetic wave. A mechanical wave is caused by a disturbance in a medium. For example, the elements of water are disturbed. Electromagnetic waves do not require a medium to propagate. Some examples of electromagnetic waves are, as we are all familiar with these examples like visible light, radio waves, X-rays, and so on. Okay, think of the ocean waves, music, tsunami, and sunlight. Now, there's an important point. The waves do transport energy and momentum, but do not transport energy. That is most important. I'll let you know how. Then you can ask the question why we should study the wave motion. So some of the applications of the wave motion are police radar guns and garage door openers. Both employ electromagnetic waves to achieve very different goals. Determining the speed of the motorists and opening the doors from several meters away. Sonographic equipment, which uses ultrasonic waves, allows medical professionals to obtain remarkable images such as the fetus in its mother's uterus. An understanding of how waves are acted to construct, or waves are how these waves are used to construct an auditorium and to perform a concerts and symphonies, that will be discussed in the later sections. So therefore, mechanical waves require some source of disturbance actually, obviously. Now, when a taut string is plucked, the disturbance produced travels along the string as a wave. Just look at the picture, for example. The disturbance in this case is the change in the shape of the string from its equilibrium shape. Its propagation arises from the interaction of each string with adjustment segments. The segments of the string move in the direction transverse, that is perpendicular to the string, as the pulse propagates back and forth action along the string. Waves such as these, in which the motion of the medium, say the medium here is a string, perpendicular direction of propagation of the wave disturbance are called the transverse waves. Waves in which the motion of the medium uh, is along, say, parallel to is the direction of, so the waves in which the motion of the medium is along the direction of propagation of the wave disturbance is called, let us say, the longitudinal waves. Sound waves are the examples of longitudinal waves. We have another wave called the water wave. The elements at the surface move nearly circular paths. Yes, of course, look at the diagram that each element is displayed with horizontally and vertically from its equilibrium position. The motion of the water elements on the uh, surface of the deep water in which the wave propagation is a combination of transverse and longitudinal disturbance.